Hello, James Flaten here, to talk about avionics bays, AV bays for high power rocketry, and in particular, setting up an avionics bay with an AIM USB altimeter, and also testing that altimeter. So, I have here a high power rocket, a little bit hard to see in my view here. There's the tip of the rocket, the nose cone, there's the tail of the rocket, and this particular rocket has a coupler section. I can start to open it up here. The coupler section is about that long, and there's a switch band in the middle that's glued to the coupler section, and there's a bulk plate at the bottom of it, and there's a bulk plate at the top of it. If I take this off, in fact, I can see the bottom of the coupler section, and inside of the coupler section is the avionics. So we call this particular coupler an AV bay. So it's a bit of a nuisance for me to work on this one, so let me pull out a different AV bay and switch my camera view here. Okay, so here's an AV bay, and there is the switch band, which is glued on. There's the section. This is labeled bottom. There's the section that fits into the lower airframe. There's the section that fits into the upper airframe. And on both ends are similar. Both ends have an eye bolt, forged eye bolt in this case, for tying to a shock cord or a recovery harness. Both ends have a cup. That's a little bit optional, but I like to put my explosive charges inside of a glove finger inside of a cup. Both ends have a terminal block, which allows me to wire an E-match on the outside and then wire from the other side of the terminal block to the inside. That allows me to put on and take off E-matches without having to open up the AV bay. And both sides have, sticking out, threaded rods. So on the top end, I have threaded rods that stick out only a little tiny bit, and they have lock nuts on them. On the bottom end, I have threaded rods that stick out somewhat more, and they have wing nuts on them, and the reason is I'm going to open this up and access the innards from the bottom end. And notice I have labeled the top and the bottom. On the side, I also see a switch. This happens to be a screw switch. It's mounted with two mounting bolts, and then in the middle is the switch itself. And so I need a screwdriver to turn the switch. So I would turn it, rotate it in to turn on the AV bay, rotate it out to turn off the AV bay. In this particular screw switch, the screw is not attached to the switch, so don't rotate it too much lest the screw fall out and you lose it and then you'd be unable to close the switch. Let's take a look inside. So to get inside of this avionics bay, I need to take off these wing nuts. This is the bottom, so I'm going to access the innards of the AV bay from the bottom. When it's in the rocket, you may actually have the top end of it riveted to the rocket, but the bottom end will be exposed when you pull the bottom end of the rocket off. So here come off my wing nuts, my second one. And then I will remove the bottom bulk plate. So one thing that I haven't done right now is I haven't run the wires from the avionics through the bulk plate. And then inside here is the sled. And the sled is a little bit shorter in this case than the coupler tube. And so I've put a stop nut right there. And so the stop nut, which is on one of the threaded rods, I could potentially put it on both, is just to keep the sled from sliding around. So I need to take that off as well. So here comes the stop nut off. And let's pull out the sled. So the sled is supposed to slide out, so it's sliding out the bottom. And it looks moderately complicated because of all these wires. Notice two of the wires actually stay attached to the coupler tube. Those are the two wires that go to this switch right here. Make sure that the wires are long enough that you can actually get the sled out without breaking anything. So let me just set these down right next to each other, and let's take a look in particular at the sled. First of all, the sled is very basic. It's just a flat piece of, in this particular case, MDF. And it has a couple crossbars. Here's one crossbar at this end, here's one crossbar at that end. And notice the crossbars, they're glued to the flat plate. They happen to have some dovetail joints, that's not necessary. And they have holes in it. The holes are important because that's where the threaded rods go through. So those holes, of course, need to match the spacing of the threaded rods and the spacing in the holes in both of the ends for both of the bulk plates. Actually, one more thing. If I look at the very top bulk plate, I will notice that not only do I have lock nuts on the outside, but I have some nuts on the inside, which means that the top bulk plate grabs, the threaded rod grabs onto the top bulk plate, which means that in this particular case, the threaded rods always go with the top, and then I remove an access from the bottom. Also notice that the forged eye bolt sticks out. There's not a nut on there, there should be, but that sticks in for a ways, and so you might want to make sure that your plate here either doesn't strike that, or has a notch so that it doesn't strike that, or possibly that gets sawed off so that more or less, that's one of the interference possibilities. In this particular case, the sled is set up so that the end of the eye bolt goes over the top of the surface of the sled, and so they don't interfere that way. Now let's look carefully at what's on the surface here. So, first of all, most importantly, here is my AIM USB. This is the altimeter. This is what's going to fire the ejection charges. Okay, remember these two wires, which go to this end of the altimeter, go to the switch, and then here's a battery, and the battery is located, is oriented so that the terminals of the battery are down. Notice the up indicator there? So it's very important to keep up and down differentiated, and I want the battery essentially upside down, so its terminals are down. That's actually a requirement of the Tripoli Club where I fly, so that when you accelerate, the battery is pushed even more forcefully into its terminals, okay? Notice that the battery here is actually in a mount, and it turns out that that mount is then screwed to the plate, to the sled, which is good, but the battery is only clipped into the mount, which is probably not good enough. And so one thing that is missing here would be some zip ties, perhaps zip ties that go around this way, zip ties that go around this way, watching out not to interfere with the threaded rods, which are going to be on this side. But yes, indeed, so this could use some zip ties to hold the battery in place. And it turns out that when this thing flies, in fact, we often put some extra electronics on the backside. Possibly something that looks like this, fairly complicated. Okay, this is called a paddle, and it needs a battery, so its battery would be back here somewhere too. So that's not what this video is about, this particular extra electronics. This is just a data logger. It's not important for the flight performance. It's only important for documenting what happens. This is the real altimeter. This is what fires the charges. This is the most important part. And from the battery positive, at this end of the altimeter I have a plus. And from the battery negative, I could go straight to this end of the altimeter, which has a minus. But what I've done instead is I've gone through the switch so that when the switch is open, none of the battery power reaches the altimeter, so the switch is able to control it. Okay, and the last thing is that I have two wires here. So this is called channel A on this side and channel B on this side. A in this context stands for apogee. And so what I do is I like to use blue wires. This is my personal preference. Blue wires for the apogee charge. That's the explosive charge I want to go off in the blue sky, high up. And then green wires on the B side, that's the explosive charge I want to go off when I'm close to the green grass. So that's the main explosive charge. And then if you think about it, the explosive charge that goes off high up, the drogue charge, is below the av bay, so these wires will run down through the bottom bulk plate, and these wires for the main charge will run up through the top bulk plate. So right now, neither of them are connected. So before I actually test an altimeter, an AIM USB, and I have a separate one that I will do the testing on, let me reassemble this av bay so you can see what that looks like. I will skip only two steps. The first step that I'm going to skip right off the bat is these wires are supposed to be fed through the coupler tube, up through the bulk plate, and then attached to this terminal block. Okay, so let's assume that these wires are in place. And then I will I'm just going to set them on the surface, but they should actually run up to the top. And then I'm going to feed the threaded rods through the 2 holes there. Make sure that you don't snag on your switch, so I'm keeping the plate here sort of as far away from the switch as I can. I'm going to slide this in. I'm going to line up the threaded rods so they go through the base here. There they are. Okay. I'm going to push this up as far as it will go, and then I'm going to put this stop nut on it to make sure it stays up there. Okay, so I'm just going through the steps for putting together the AV bay. And the only step I skipped is running those green wires up through the upper bulk plate. I would have to do that before I put the sled into the tube. Okay? Now here's the next step, and I'm also going to skip this step, is taking these wires, which are longer than they would need to be, and running them through a hole in the bottom bulk plate and attaching them to this terminal block. But I'm going to skip that step also and just tuck them inside there. And then I will slide my bulk plate. Notice my bulk plate has this outer area, which is the same diameter as the coupler tube, so it fits inside the airframe, and then this inner area, which is slightly smaller, so it fits inside of the coupler tube. That makes this a self-centering bulk plate. Also notice that the threaded rods are slightly off-center, they're a little bit low, and the eye bolt is slightly off-center, it's a little bit high. That's just to make sure that the sled, for instance, can be right in the middle, and that things don't interfere with each other. And then I will hold that in with these wing nuts, so I'll put those back on. There's one. Here comes the second one. Okay, so one last time, from the very top, just thinking about threaded rods and nuts, I have here a lock nut. Right underneath this bulk plate, I have a regular nut. And then there's the sled, and then there's the stop nut to keep the sled from sliding around, and then this bulk plate, and then here is the wing nut to hold the whole thing together. And then I have very good tension strength, so when I pull really hard on the top and the bottom, as I attach my recovery harness to those 2 eye bolts, this will be strong enough. And then during the flight, this part will be riveted to the upper airframe. I do need to be able to get it apart so I can install this explosive, and it's E-match. And then I will rivet this to the upper airframe, and then this will be a friction fit, so then during the flight, this friction fit will come apart at apogee when I fire this explosive charge. There's also, of course, the motor eject, and the motor eject might be used to back up this explosive charge. And then later on, as the thing gets closer to the ground and senses that it's getting close to the ground, it will fire the upper charge, pressurize the upper airframe, and blow off the nose cone, which was held in place with shear pins, and these rivets will stay in place, and so this part does not separate during the flight. Now let's take a look at an actual AIM USB. So that's what it looks like. There's the AIM USB. In this particular case, just for testing purposes, I've attached a 9-volt battery snap. This is not the kind of 9-volt battery. I would propose you use Duracell copper top batteries instead of this one. I just don't happen to have one that's alive enough for this demonstration. And my apologies for the hiss that you might hear in the audio of this video. I had to turn off all of the Zoom audio devices which try to make beeps go away in particular, and the reason is I want you to be able to hear the beeps. So when I power this thing up, before I power it up, let me just remind you, so there's no switch here. I'm just going to power it up by applying the 9-volt directly to this battery snap. The plus for the battery goes to the V plus, the minus to the battery goes to the V minus. In the other case, there's a C in between that's not attached to anything, and so in the other case, the plus of the battery went to the V plus, and then the minus of the battery went to the switch, and then the switch went to the V minus. And it could have actually gone to the C, and then you could have done the switch to the C and to the V minus. Okay, what I've done here actually is I've put 2 LEDs. These happen to be LEDs that have safety resistors built into them. And so one of the LEDs is on the A channel, one of the LEDs is on the B channel. I chose a blue LED for the A channel. I chose a green LED for the B channel. So this one is blue, this is the drogue, this is green, this is the main. And it says A plus B, and so the middle here is plus. That means when I put LEDs, I need to make sure that the longer lead, the plus lead, goes into the middle, and the shorter lead, the minus lead, goes to the A letter or to the B letter. When you're putting E-matches on these things, then it doesn't matter what is plus and what is minus, but for this LED demonstration, it is important. So here's what's going to happen when I first power it up. It's going to start to beep, and it will beep 4 messages to me. The first message is, do I have enough memory? And if the answer is I'm fine with memory, it will go beep, beep, beep 3 times, short beeps. And if it is out of memory, it will go beep, 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 very slow beeps 3 times. So I need to listen for shorter or longer beeps. The first 3 beeps will be from memory. The second 3 beeps will be for battery voltage. So in other words, it wants to give me insight into whether the battery is likely to have enough voltage to accomplish its task. And then the third beeps are whether there is anything attached to the A channel. And the fourth is whether there's anything attached to the B channel. Just for fun, let me disconnect what's attached to the A channel. So I'm just going to remove 1 lead of this LED. That means that I should get, if everything is going fairly well, 3 short beeps for memory, 3 short beeps for battery, it's a good battery, 3 long beeps for channel A, because nothing's attached to channel A anymore, and then 3 short beeps for channel B. Let's see if that happens. And then after that, it will go into a very regular beep, 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 beep. That means waiting for launch, waiting for launch. So here we go. That was 3 short. That was 3 short. That was 3 long. That was 3 short. Now it's waiting for launch. Notice that this particular LED that's still attached is actually glowing. Just a little bit, okay? That's normal. So what happens is it delivers a little bit of current to these channels, but not enough to fire an explosive charge, for instance. Let me put that other LED back in place. Okay. And so now when I turn it on, I should be able to, first of all, see both of them glowing, and I should get a different beep pattern, 3 short beeps, 3 short beeps. And then what I'm going to do while it's beeping is I'm going to pull out a straw, and I'm going to suck on the pressure sensor. So the pressure sensor is this little tiny, right there. This is the pressure sensor, and if I suck on the pressure sensor and reduce the pressure, it should notice that something's going on, and it should say, oh, I think that's a launch. And if it detects a launch, it should fire the drogue charge, and sometimes it fires the main charge, and sometimes it doesn't. It depends a little bit on how effectively I suck. So I can force it to launch, or think it's launched, and it will fire the drogue for sure, and sometimes I manage to get it to fire the main, and sometimes I don't. The main is set to fire at a specific pressure after the drogue is fired, and this is not really a launch, and therefore I'm not always successful in getting them both to go off. But let's listen for the beeps, and watch for the glow, and then I'm going to suck on the pressure sensor and see if I can get the thing to do something. First of all, they're both glowing. 3 shorts, 3 more shorts, 3 more shorts. Ah, that's good. Now it's time for my manual test with a straw. Watch to see if the lights fire. And you'll know the lights fire because they'll get very bright. Okay, fair enough. I got only one of the 2 lights to actually fire. It's hard to suck in a reasonable pattern for it to think that you are actually descending. What it's doing right now is it's beeping out the altitude. Let's listen for these beeps. Here we go. 2, 3, 4, 5, 6, 7, 7, 1, 1. 711, okay? So in other words, based on the reduction in pressure, it believes it went to 711. What are the units? I think they're meters. I'm not 100% sure. So now I want to actually take a quick look at the software that is used to set up this device. And so I'm going to plug in the device with micro SD. And then I'm going to switch over Okay, so this is the AIM USB software. You'll need to download the software, it's free. Just type in AIM space USB space download and you'll find Inticore Corporation, inticore.com I think, and ask to download the most recent version of the AIM USB software. And it's very basic software. In fact, this is the main screen and there's not really anything on the screen. If I click up here on Tools, I can say device settings. Let me try device settings first. And when I say device settings, I need to get rid of my hide floating meeting controls. Thank you. Okay, so here is what it says this device is programmed to do right now. This device is programmed to fire line A at apogee, exactly at apogee, no delay, and it's going to keep the light on. It's going to apply the electricity for 20/10 of a second, another for 2 full seconds. Notice down here it says devices found, devices connected, firmware is 4.0, altimeter is found, reading successful, successful. This is good. These are the settings that come from the factory. Channel A is set to fire at apogee for 2 seconds, and channel B is set to fire at a specific altitude, and that altitude is 150 meters above ground level, which is close to 500 feet, with no delay, so exactly when you notice that altitude, and fire again for 2 total seconds. These are reasonable settings for almost all the rocket flights that I do, at least with classes, and therefore I usually don't fiddle with them at all. And if somebody does fiddle with them, you can always get them back by clicking on Reset Settings here. If you say Read Settings, it will read the device and ask it what the settings are. If you want to change the settings, then you have to click Write Settings so it remembers what changes you made. And if you're not sure where you're at, just click Reset Settings and we'll go back to these settings, which are the manufacturer settings. I'm going to go back to Tools here, and I'm going to say Control Device. And so here I have 4 buttons, one of which is grayed out for reasons I don't fully understand. I can click Read Pressure, and it says, I think you're at 309.3 meters or about 1,000 feet. That's actually true here in Minnesota. I can click on Read Battery Voltage, and it says 0.1 volts, which is not true. It should have said 0, and the reason is I don't have a battery attached. So let me put a battery on the device right now. Since it's plugged in, it won't actually go through its beeping pattern, and let me click Read Battery Voltage again, and there it is, 9.5 volts. So a 9-volt battery, when new, should read more than 9 volts, in fact. So if you see something that's 8 volts or 7 volts, that means the battery has been used, and you probably should switch out for a new battery. And then, then I have the option to fire the lines. So here's what I'm going to do without even changing cameras. I'm going to just hold this up in front of this camera here. Notice the 2 are glowing, both of them are glowing a little bit, and if I say fire the lines for 2 seconds, there they go. So this is a way of testing whether or not these things will in fact go off. Now, were I able to emulate launch, and I apologize that I can't, I've actually reached out to the manufacturer asking them why is this happening, but were I able to emulate launch, here's what it would do. It would do a countdown, actually it's a count up for about 14 seconds, and then it would say, okay, pretending to launch, and then it would say, firing the first channel, and it would make one of the lights go off, and then it would wait for a while, and then it would say, firing the second channel, and it would make the second light go off. So that's what emulate launch is supposed to do, test the entire procedure, but for reasons I don't understand right now, emulate launch is turned off. I'm not worried about the device, I'm a little bit worried about the software. Let me do one last thing, and let me take a quick look at some data. And so when you download the software, it comes with some data from some example flights, and let me just open up the very first one, which is called 24.01.2013, and if I open that, it will draw the following very, very basic graph. So let me just show you, and the reason is this is the kind of graph you will get when you get data of your own. So first of all, this is time going horizontally, although it's not labeled as such. And then vertically there are 2 things. One is altitude and one is speed, where upwards means positive speed, downwards means negative speed, so it's velocity. So what I see is, in this particular data set, the rocket goes up to some altitude, and so this would be apogee, and then when it reaches apogee, notice this red bar. This red bar means line A is firing. So line A apparently was set to fire at apogee, and then what happens is the rocket comes down, it decreases in altitude at a linear rate. That would be coming down under some sort of a drogue. And then when it reaches some specific altitude, one thing that's a nuisance about this graph is that the axes aren't labeled at all. But you can download the data and make your own graphs, which would be better. But it comes down at some specific rate, and then it fires the second channel, channel B, and then after it fires channel B, it comes down at a different rate, a different slope. If I look at velocity, I notice that from the beginning of the flight, it picks up speed, and then after the motor burns out, it slows down, and it's still going up, but it's going up more slowly. And then when it stops going up, so in other words, when it reaches this line, when it is going up at 0, in other words, it's reached the peak, that's when it fires the first charge. And then it comes down at some negative velocity. Let's call that negative 30. I'm just making that up, but some number, negative velocity. And then it fires a second charge, and then it continues coming down at a different, smaller negative number, like negative 15 in some units. There's one thing that's a little weird about this, and that is right at this point here, notice that the altitude, which was at some altitude, let's say maybe 150 meters, suddenly the altitude seems to dive to 0 and then go back up. What that means is this altitude is based on pressure, and apparently when this explosive charge went off, some of the pressure leaked into the av bay, and it pressurized the av bay. And when it pressurized the av bay, it got its altitude wrong just for a moment. And then after the rocket actually opened up and the av bay pressure returned to the appropriate value, then the altitude returned to the appropriate value. So this particular downwards spike in altitude, and it corresponds to a downwards then upwards spike in velocity, don't take those too seriously. That's just because this is a pressure sensing device, and some of the explosive pressure reached into the av bay and messed up the sensor just for a moment, and then it kind of recovered. So one more time, as this thing goes up, it reaches apogee, and when it reaches apogee, it fires one of the charges, and then at that point, it continues to fall under one parachute at some rate, and then when it reaches a specific altitude, it fires the second charge, and then it continues to fall under 2 parachutes now, and so it continues to fall, but at a slower rate. When you have your own data, you will be using things like export CSV in particular. So if I go to Tools and say Download Data, it shows that there is a small amount of the memory. This is a memory bar, and a small amount of the memory is used up. This is why it wants to check to make sure you have some memory left before you fly. And if I say Read Data, what it will do is it will read values out of the memory. It says there are 30 data points in the memory. That's because I loaded this flight of sample data. And then I can clear the device, for instance. It's probably a good idea to clear the device before you fly it, just to make sure you have as much memory as possible. Okay, that's what I've got as far as nav bays, how to organize them, how to build a sled, what to put on the sled. Make sure that you have a switch on the sled so you can turn on the electronics after the thing is completely sealed up. We'll be installing ejection charges on the top and the bottom, especially on the top for the main parachute. You could maybe get away without an ejection charge on the bottom and just say the motor eject will pull out my drogue. I like to pull out my drogue with my electronics and let the motor eject be a backup. And then what to expect as far as the device itself, what it should beep when you first turn it on, and then what it should beep after it has, while it's waiting to launch, and what it should beep after it's flown. So again, when you first turn it on, you need to listen carefully because these beeps aren't that loud. You might have to put your ear right up against the rocket, in fact. And you expect 3 short beeps for good memory, 3 short beeps for good battery, and then 3 short beeps if you have something attached to channel A, and 3 short beeps if you have something attached to channel B. If you're using the device not to fire charges, but just to document a flight, you might have long beeps because you don't have anything on channel A or channel B. And if any of those sets of beeps are not what you expect, you must stop. You must stop and figure it out and fix it. So for instance, if your battery is low, don't say, oh, well, it's beeping, it's probably okay. Don't say that. Say, it's low, it's not okay, I need to replace that battery. Similarly, if it says the memory is no good, that means you need to go and clear the device and then try it over again. Make sure you don't power up your electronics when you have real explosive charges attached to it. for fear, this is not a big fear, but it could possibly happen, that the electricity in the device makes the charges go off early. So you're not supposed to, but don't power up your device until it's on the rail, ready to fly. And then if you happen to pop a charge, then all it will do is, knock the nose cone off, and you can easily reset that and still live to fly another day. That's what I've got.